Good morning, all. I am Biplab Ojha, faculty member of St.Joseph'S group of institution. Today, I am going to discuss the very important topic, and the topic is quantum number, and this topic is belong to atomic structure. This topic is very important in 9th, 10th, 11th and 12th, especially the most important topic for NEET and JEE. Okay, let's start. Quantum number. What does it mean that? First of all, quantum number consists of four numbers. One is principal quantum number, second one is azimuthal quantum number, third one is magnetic quantum number, and last one is spin quantum number. First of all, why quantum number introduced in atomic structure? Because quantum number gives proper address of an electron. Address means, for example, someone wants to admit in St. Joseph group of institution. When he want to take admission in St. Joseph group of institution, first of all, he or she know about the address of St. Joseph group of institution. For example, we know that there are different kind of countries. For example, Australia, India, England, and etc. First of all, he has to choose which country he or she belongs to. First of all, he identified he belongs to country India, and we know that in India there are different kind of state, and then he has to select which state he has belonged. For example, he has select Odisha. Second, in Odisha there are different kind of district. Then he has to select which district he is belong. That's why quantum number gives idea about or gives address or complete information about an electron. Address means position and their energy and which orbital he occupied. There are different kind of data which can give by the term quantum number. First of all, there are four quantum number. First one is principal quantum number. Which are represented by small n, and second one is azimuthal quantum number, which is represented by small l, and third one is magnetic quantum number, which also represented by small m, and last one is spin quantum number, which is represented by small s. Now we have discussed one by one, these four set of quantum number gives completely address of an electron. First of all, we start from principal quantum number. Let's start. First, principal quantum number is represented by small n, and second one is principal quantum number gives idea about cell. Let's see. Principal quantum number is represented by small n, and second one is principal quantum number gives idea about cell. Now question arises in our mind, what do you mean by cell? We know that, suppose, and one more thing, we introduce principal quantum number. I want to show complete structure of atom. Now see, we know that in an atom, suppose let's say we imagine a circle, and this is the center of circle. Imagine an atom. We know that the smallest individual particle of an element is known as atom, and at the center of atom nucleus is present, and inside the nucleus proton and neutron are present, and around the nucleus electron revolves, or otherwise we can say that electron revolves around the nucleus, and this path is known as cell or orbit. Okay, now see in the structure. For example, suppose this is a nucleus, and inside the nucleus proton and neutron are present. I represent P for proton and N for neutron, and around the nucleus electron revolves. Let's see. This is the path where electron revolves. Second one is, this is the path where electron revolves. Okay, this is the diagram or structure of atom, and in cell or orbit electrons are present. Okay, let's come to the previous page. Principal quantum number gives idea about cell. What does it mean? That where cell electron revolves around the nucleus. Now question arises, suppose we say n is equal to 1 or n is equal to 2. When I say n is equal to 1, n is equal to 1 means the first cell or the cell closest to the nucleus. For example, suppose say this is the nucleus of an atom. This is the first cell or closest cell to the nucleus. After first cell, next cell comes, and this is the second cell. And we know that this is called K cell, and this is called L cell. Okay. Next come to the cell. This cell is known as M cell, and we know that next for K cell the value of n is equal to 1, and similarly for L cell the value of n is equal to 2, and for M cell the value of n is equal to 3. When I say n is equal to 1, this is called first cell, and this is your second cell, and after second cell, third cell comes. That means n represents cell, or n gives idea about cell. That means when I say n is equal to 1, this is first cell, n is equal to 2, second cell, n is equal to 3, this is your third cell, and so on. Okay. Next, principal quantum number, which is represented by n, gives idea about size and energy of the cell. Next, come to the second point. This is most important point. Please focus. Point number 5. The statement, as the value of n increases, the energy also increases, which is the statements belongs to principal quantum number. Let's I write, as the value of n increases, energy also increases. Now we discuss this point completely. My question is, how or when the value of n increases, energy also increases. Let's please explain it, or explain now. Suppose this is your nucleus, and inside the nucleus proton and neutron are present. This is your first cell, this is your second cell, this is your third cell, and we know that for first cell, n is equal to 1, for second cell n is equal to 2, and third cell n is equal to 3. My point is, when the value of n increases, energy also increases. Let's see. Suppose we go from towards right. Suppose the value of n is equal to 1. When the value of n increases, that means n is equal to 2 and n is equal to 3. That means n is equal to 1, n is equal to 2, and n is equal to 3. Students, you know that when I say n is equal to 1, it means first cell, n is equal to 2, second cell, and n is equal to 3, third cell. That means K cell, after K cell, L cell comes, and after L cell, M cell comes. Okay. My question is, this is the order of energy. Now we understand this statement completely. Before we understand this concept, we have to know another concept. That concept completely interlinked with this concept, and the concept is attraction and repulsion, and how energy is directly linked with attraction and repulsion. Now we clarify them. Let's see, students. This is your attraction, and another point is repulsion. And very small thing, we know that opposite charges are attracts each other, and same charges or like charges repels each other. Okay. Now I write same point. Opposite charges attracts each other. Now one question is, when I say opposite charges, that means positive negative or negative positive, and we know that there are only two type of charge. One is positive charge, another is negative charge and neutral. Proton have positive charge, electron have negative charge and neutron becomes neutral. When I say neutral, neutrals means when equal number of positive charge is equals to equal number of negative charge, or number of positive charge is equal to number of negative charge. This state we call neutral state. Okay, positive charge means we comes to atom. Inside the atom, proton and electron are present. Proton have positive charge, electron have negative charge. When I say equal number of positive charge and equal number of negative charge, that means the number of positive charge becomes equal to the number of negative charge. Okay, let's say that means opposite charge means either positive charge or negative charge, or negative charge or positive charge. Okay, let's come to the first point of repulsion. Repulsion means we know that like charges, or otherwise we can say that same charges repels each other. Repels each other. Same charge means when negative charge came contact with negative charge, or positive charge gets contact with positive charge. That means when same charge close to each other, it repels each other. Okay, come to the next point. Now we come to the how energy is linked with, or what is the relationship between energy, attraction and repulsion. Energy means, for example, we know that when attraction occurs, energy releases. And we know that suppose this is a system, when the body loses its energy, that means the total energy of the system decreases. Okay, that means when attraction occurs, energy releases and the whole energy of the system gets decreases. And when repulsion occurs, energy increases. That means energy increases. Okay, when I say the relationship between, suppose energy is directly proportional to repulsion and inversely proportional to attraction. That means when repulsion occurs, the system of the body increases. When attraction occurs, the whole energy of the system decreases. And the most important point, the relationship between stability and energy. Let's say right. This is the relationship between energy and stability. All the chemistry students must know about everybody or every reaction wants to stay in stable form. That means this is the inverse relationship between energy and stability. That means we say that, or I say that, when energy increases, that means inversely proportional. When the energy increases, the stability becomes decreases. When the energy increases or energy decreases, the stability becomes increases. That means everybody wants to stay in stable form. Okay, that means let's come to the structure of atom. We know that this is the first cell, this is the second cell, and this one is third cell. Here electron is present. Also in second cell electron is present, and in third cell electron also present. We know that positive charge, that means proton and electrons are present in an atom, and proton have positive charge, electron have negative charge. And we know that all the positive charge are concentrated at nucleus or inside the nucleus. And all the positive charge or all the protons are concentrated inside the nucleus. Suppose here electron is present and electron is also present in second cell and electron is also present in third cell. My question is, which electron feels more attraction and which electron feels less attraction? Because we know that this is the electrostatic force of attraction between positive charge and negative charge, and this is the electrostatic force of attraction is directly proportional to or linked with the distance. That means when distance decreases, attraction increases. When distance decreases, attraction increases. When distance increases, attraction decreases. And we know that when attraction occurs, energy of the system decreases, and when the energy of the system decreases, the system or stability increases. Okay. Suppose one electron belongs to first cell and one electron belongs to third cell. That means the electron which is present in first cell feels more attraction as compared to electron present in third cell. That means when distance increases, attraction decreases. When attraction decreases, that means repulsion increases, and we know that when repulsion increases, energy of the system increases. When the energy of the system increases, the stability of the system decreases. This is the negative point of that. Okay. This is the complete understand of as the value of n increases, energy also increases. And last point is the maximum number of electron. The maximum number of electrons present in a cell is given by 2n square is given by 2n square. For suppose in first cell, and we know that first cell the value of n is equal to n. Suppose my question is, how many maximum electrons are present in first cell, or how many maximum electrons are present in second cell, or how many maximum number of electrons present in third cell. Let's discuss it. When I say first cell, that means the value of n is equal to 1 and the formula is 2n square. In first cell, 2 into 1 square, that means 2 electrons. That means in first cell, 2 electrons can only present, not more than 2 electrons. The formula is 2n square. Suppose in second cell, n is equal to 2. When this value we put or I put into 2n square, that is 2 into 2 square, that means 8 electrons. And last one is, suppose in third cell, n is equal to 3, that means 2 into square, 18 electrons. That means I confirm that in first cell 2 electrons is present and in second cell 8 electrons is present and third cell 18 electrons is present. Okay, that means simply I remember that, or we need remember that n is equal to 1 first cell, n is equal to 2 second cell. That means when I say n is equal to 3, that means the electron is present in third cell. Suppose I write n is equal to 4, that means the electron present in fourth cell. Suppose I write n is equal to 5, that means the electron present in fifth cell. Now come to the second quantum number, and second quantum number is Azimuthal quantum number. Principal quantum number gives idea about cell or orbit, and Azimuthal quantum number gives idea about subcell. That means number of subcells is present within the cell. That means question arises, how many subcells are present in a cell? For example, suppose I say first cell. That means in first cell, how many subcells can present in first cell? How many subcells are present in second cell? And how many subcells are present in third cell, and so on. And let's come to the second quantum number, and second quantum number is Azimuthal quantum number, and Azimuthal quantum number is represented by small n. Azimuthal quantum number is represented by small n. When principal quantum number gives idea about cell, similarly, Azimuthal quantum number gives idea about subcell. That means, first of all, it is represented by small n. It is represented by small n, and it gives idea about gives idea about gives idea about subcell. Gives idea about subcell. Now, my question is, how many number of subcells are present in a cell? Let's come to the point. This is the important point. For each value of L, there exists a subcell, and the value of L lies between 0 to n minus 1. Please focus this point. For each value of L, there exists a subcell, and the value of L lies between 0 to n minus 1. Next, repeat, the value of L lies between 0 to n minus 1, and n represents principal quantum number, and also I know that, or we know that, n represents cell number. That means when I say n is equal to 1 first cell, n is equal to second cell, and n is equal to 3 third cell. Now, we discuss the subcell is present within the subcell. Suppose this is your nucleus, proton and neutron present inside the nucleus. Suppose this is your first cell, and for first cell, the value of n is equal to 1, and second cell, the value of n is equal to 2. And we discussed before we discussed, for each value of L, there exists a subcell, and the value of L lies between 0 to n minus 1. Now, discuss for first cell, and we know that for first cell, the value of n is equal to 1, and the value of L lies between 0 to n minus 1. And we know that for first cell, the value of n is equal to 1. When I put this value into this, that means 1 minus 1, 0, 0 to 0 is 0. That means the value comes from one value, that is L is equal to 0. When I say L is equal to 0, that means only one value comes. Since one value comes, that means one subcell is present in first cell, and this subcell is S subcell. This subcell is S subcell. This subcell is S subcell. Let's come to the second cell, and we know that for second cell, the value of n is equal to 2, and the I know that the value is lies between 0 to n minus 1. When put this value, that means 0 to 2 minus 1, 0 to 2 minus 1 is 1, that is the value is 0, and another one is L is equal to 1, or another value is L is equal to 1. Since two value comes, that means two subcells are present in second cell. When I say L is equal to 0, that means A subcell, or alternatively we can say that for A subcell the value of L is equal to 0, L is equal to 1, that means P subcell, or alternatively we can say that, or I can say that for P subcell the value of L is equal to 1. That means in first cell only one subcell is present, this is, or that is A subcell. In second cell two subcell is present, that is L is equal to 0 and L is equal to 1. That means A subcell, and second one is P subcell. Let's come to the third cell. For third cell, we know that the value of n is equal to 3, and we know that the value is lies between 0 to n minus 1. When I put this value, that means 0 to 3 minus 1. 3 minus 1 is 2. That means L is equal to 0, L is equal to 1, L is equal to 2. That means there are three value comes for third cell. Since three value comes, that means three subcells are present in third cell, and we know that when I say L is equal to 0, that means A subcell is present. When I say L is equal to 1, that means P subcell is present. When I say L is equal to 2, that means D subcell is present. That means in third cell there are three subcell are present. One is A subcell, and second one is P subcell, and third one is D subcell. Always remember that alternatively that for A subcell the value of L is equal to 0. For P subcell the value of L is equal to 1, and for D subcell the value of L is equal to 2. That means in first cell one subcell is present, that is A subcell, and in second cell two subcell is present, that is A subcell and P subcell, and in third cell there are three subcell is present, one is A subcell, P subcell and D subcell. And also remember that for A subcell the value of L is equal to 0, for P subcell the value of L is equal to 1, for D subcell the value of L is equal to 2, and last cell, that is N is equal to 4, that is your fourth cell. And again repeat that the value of L lies between 0 to n minus 1. Again I repeat this point, for each value of L there exists a subcell, and the value of L lies between 0 to n minus 1. Suppose when we put this value, that means 0 to 4 minus 1, that is 0, 1, 2, 3. That means there are four values comes. One is L is equal to 0, L is equal to 1, L is equal to 2, and another one is L is equal to 3. And we know that L is equal to 0, which subcell? A subcell. L is equal to 1, which subcell? P subcell. L is equal to 2, which subcell? D subcell. And L is equal to 3, which subcell? F subcell. Again we repeat that for A subcell the value of L is equal to 0, for P subcell the value of L is equal to 1, for D subcell the value of L is equal to 2, and for F subcell the value of L is equal to 3. That means suppose let's all the things are kept in one page. Suppose this is your cell and this is your subcell. Okay. For first cell there are one values of L, that is L is equal to 0. L is equal to 0 means which subcell? S subcell. Acha. When I write n is equal to 2, n is equal to 2, n means principal quantum number, and principal quantum number gives idea about cell. When I say n is equal to 2, that means second cell. That means in second cell, there are two subcells present. One is S and another one is P. That means there are two values come, L is equal to 1 or L is equal to 0, and L is equal to 0, S subcell. L is equal to 1, P subset, and n is equal to 3. There are three values, L is equal to 0, L is equal to 1, L is equal to 2. That means in first cell only one subcell is present. This is your S subcell. In second cell two subcell is present, S subcell and P subcell. And in third cell three subcell is present, S, P and D. Last one is n is equal to 4. N is equal to 4 means L is equal to 0, L is equal to 1, L is equal to 2 and L is equal to 3. When I say L is equal to 0, that means S subcell. L is equal to 1 means P subcell. L is equal to 2 means D subcell. L is equal to 3 means F subcell. That means there are four subcells are present in fourth cell. One is S, second one is P, third one is D, and last one is F subcell. And the last point is Azimuthal quantum number, which is represented by L. L gives idea about, this is very important point, L gives idea about the shape of the subcell. The shape of the subcell. And generally we know that there are four kind of subcell. One is S, another one is P, third one is D, and last one is F. That means S subcell, second one is P subcell, third one is D subcell, and last one is F subcell. And the shape of the S subcell is spherical. That means the shape of the S subcell is spherical, and the shape of the P subcell is dumbbell, and the shape of D subcell is double dumbbell, and the shape of F subcell is complex. Okay, this is completely information about Azimuthal quantum number. After Azimuthal quantum number, only there are two quantum numbers left: magnetic quantum number and spin quantum number. And we will discuss this quantum number in next class. Thank you.